All right, this is the video for the chapter P test. That's the chapter on preparation for college algebra. And so we're just going to go through and try to answer these questions as quickly as we can. Question number 1 has the numbers 3, -2/3, 0.25, √7, and 0. And we're asked to classify all the numbers as natural, whole, integer, rational, or irrational. And we're supposed to use every classification type that we can. So for instance, number 3, we're going to start with the most simple, is a natural number. Natural numbers, remember, are counting numbers. And since 3 is one of the numbers we would count on our fingers, we can say that it is a natural number, which also means that it's every other classification underneath it, which means that it would also be a whole number, which means it would also be an integer, which means it would also be rational. The only type of number that it doesn't fit the description of is irrational. Now, -2/3, that's a fraction. It cannot be written unless it is a fraction or decimal, and since that makes it not a natural number, because it's not a counting number, it's not a whole number, because whole numbers are counting numbers and 0. Integer, positive, negative, it is negative, but it still has to be a counting value when it's an integer. So this must fall into the category of just rational. Okay? When we come to 0.25, I'm trying to sneak one past you. It is a decimal, but it's a decimal that can be written as a fraction, which makes it also rational. Okay? √7, that is a square root that doesn't reduce and can't be written, and because it doesn't reduce, it cannot be written as a fraction. So this is an example of an irrational. And then the last number is 0. It is not a counting number. If you think about counting on your fingers, it is not the number you start with when you stick your first finger up. You normally start with 1. And so 0 is not a natural number, but it is a whole number, because it is a whole value, 0, which also makes it an integer, and therefore also rational. You could write it as 0/2, 0/3, 0 over anything, and it would still be rational. So that's what that should look like somewhat. The rest of these, a lot of these are simplification problems. So I'm going to kind of go through them pretty fast. +3 -2⁴. PEMDAS says we work on parentheses first, doing the inside of the parentheses. We can't actually add the x of 3, so I can't do parentheses at this stage. I can, however, do my exponents. So this is really important. It's not -2⁴, it is -2⁴. So I'm only going to focus on the 2⁴. And so 2⁴ in my calculator or done by hand should come out to 16. Now I'm past exponents, I'm looking at multiplication and division. This right here, this distribution, is a form of multiplication that I can do right now. Meaning I'm going to have 6x plus 12x plus 36 minus 16. And now I'm looking at just addition, subtraction of like terms. It's going to give me 18x plus 20. So there's the answer to 2. 3, somewhat similar, is 2x to the 3rd times 7x to the -4th times -3x squared. The key to doing question number 3 is really just understanding that we're going to multiply. There's no addition or subtraction, which means it's not a distribution problem like foiling. It's nothing like that. All we're going to do is multiply the coefficients, 2, 7, and -3, and then we'll multiply the x's and just combine them. So 2 times 7 is 14 times -3. It's going to be -42. Now when I multiply the x's, the rule is that we add the exponents. And so I'm going to add 3 to -4, that makes -1. -1 plus 2 is +1, so that becomes -42x. Or if it makes you feel better, you can put an exponent of 1. Otherwise, it's the same thing. Question number 4. I assume you can pause the video and go back if there's something you need to write down before I drop or change the page there on you. 3x to the 7, y to the -12, z to the 3rd over 12x to the 10th, y the 7th z squared, all cubed. I could try to distribute the cube now, but I actually want to try and reduce the fraction as much as I can before I do that. So I'm going to keep the cube as I go through the first stage. 3 over 12 becomes 1 over 4. I'm going to put a 4 down here. I don't really need to put the 1 on top. I can if I get nothing left, but I think I might have something left. With the x's, I'm going to remove the smaller one. And since 7 is smaller, I'm going to subtract 7 from both of the x's exponents. That should leave me with x to the 3rd on the bottom. In the y's, it looks like the negative 12 is smaller. To make it go to 0, I'm actually going to add 12 instead of subtracting it. You could say it's subtracting a negative 12, but same as adding 12. So this becomes y to the 19th. And then with the z's, I'm going to minus 2, leaving me with just a z on top. I still need to distribute the cube. Keep in mind it distributes as an exponent, not as a multiplier. It might multiply exponents, but it is an exponent that we're distributing. So we're going to get z to the 3rd over, now when we do 4 to the 3rd, it's really important we understand that's not 12, it's 4 times 4 times 4, which turns out to be 64, x to the 9th, y to the 57th. It's a big number, but it's just a number. Nothing to worry about. Number 5 starts into square roots. We've got the square root of 5x to the 5th times the square root of 10x squared. I like to do these by just multiplying together like we did on question number 3 and then working the problem out of the square root on its own. So we get square root of 50 x to the 7th. Remember, you add exponents when you multiply x's. And now I just want to start breaking it down. I got to remember it's a square root, so when I split the 50, it's really nice to split it so I get a square root, like 25 and 2. The reason I like that is I know the square root of 25 is 5, and I know there's a root 2 left behind. Now when it comes to the root 7, and the square root of x to the 7th, what I'm going to do is I'm going to write it out 7 times, just to make sure that this idea makes sense. To get out of a square root, it takes 2 matching pieces. So I have how many groups of x twice? I have 3 of them. So for each time I pull one of these out, you think about pulling out an x. That should leave me with x to the 3rd on the outside. And there was this single x that could never partner up, and so I'm going to keep that behind inside the square root. If it had been a cube root, I'd have to take 3 out at a time and only represent it with those singles. So number 6 is about adding and subtracting roots. So we get 10 root 12 minus 6 root 75. The roots right now aren't the same, so I can't physically combine them. I have to get them to have the same root inside. So when I look at the 12, I think of it as 4 and 3. Again, the goal is to get a square root that you can reduce. So the square root of 4 is 2. I still have to multiply that by the number that was out front, so that makes this 20 square root 3. That was what was left over. Minus, now when I do the 75, I'll use 25 and 3. Square root of 25 is 5. That multiplies by my 6 to make 30. And I still have root 3. The key here is that the 2 roots are identical. I have a root 3 and a root 3. So now I just treat them like x's. This is no different than 20x minus 30x. If I did that, I'd get negative 10x, but the x in this problem is root 3. So you should be able to solve it much that same way. Question number 7 is a big one, it looks like. It's a 4th root, which means it takes 4 identical pieces to get out. 1250 x to the 5th, y to the 10th. And so we're going to start breaking down that 1250. Because it's a 4th root, instead of trying to memorize all the 4th roots, I'm just going to break it until I find 4 matching things. I know that a 5 will go into 1250. And if I break that down, I think I get 250. And then if I break the 250 down by 5, again, okay, I would get, is that 50? And if I break the 50 down, I get 5 and 10. And if I break the 10 down, I get 5 and 2. So when we come back along the way, I'm looking for 4 matching pieces. Right here I see I have 4 5s. What that means is that that information can come out of the root, and anything that didn't have that group of 4 gets to stay behind. So I see that I've got a 5 times the 4th root of 2. The question is, what about the x's and y's? Well, if you think about the x, it's supposed to show up 5 times. Well, if you did it, you would take 4 of them. That comes out, making an x. And I'd have the single x left over to put back inside. The nice thing is if we start thinking about the number and thinking about the idea of division, that's really how this works. What is 10 divided by 4? The answer is it's 2, and I'd have 2 fourths left over. So if you think about it, there's 8 of them, 10 y's. There's every 4 of them, you pull one out. So you should be able to pull 2 y's out, because there'd be 2 groups of 4, and I would have y left over twice. If you want to write out all 10 of them, that totally makes sense. You could save yourself some time by trying to just reason through it in terms of division. Think of it like a fraction as a mixed number, like 2 and 2 fourths, that kind of an approach. Number 8 is similar to that idea. It's the cube root of x to the 6th, y to the 9th. And I ask you to write them in rational exponent form first. And since it's a cube root, these would be over 3. And it's going to be 6 over 3 and 9 over 3 for each of those. And then the goal is simply to reduce them. It turns out that 6 over 3 makes it x squared, and 9 over 3 makes it y cubed. And so that would be the end of that question. All right, so we're going to go to number 9. When you flip the page over on the test review, things change pretty dramatically. We go back to a lot of simplification through multiplication on 9, 10, and 11. Number 9 says 2x plus 6 multiplied by 3x squared plus 10x minus 14. Now, we've talked about before using a grid to do this. I'm just going to go ahead and use the arrows and talk about distribution by parts or foiling if you want. The 2x times 3x squared is 6x cubed. 2x times 10x is going to be 20x squared. 2x times negative 14 is negative 28x. That took care of the 2x. Now when I go ahead and do the next layer of distribution, 6 times 3x squared turns out to be 18x squared. I'm writing it underneath the other x squared just to make my life easier to combine my like terms later. 6 times 10x turns out to be a positive 60x, and 6 times negative 14 is negative 84. When I combine all my like terms, I get 6x cubed plus 38x squared plus 32x and minus 84. Okay, and so that's number 9. 10 is actually a little bit easier, but it looks like the kind of thing that confuses people from time to time because they see the 2 sets of parentheses. I have x to the 4th plus 4x squared plus 2x minus 21. And then I have x cubed plus 4x squared minus 6x plus 5. Now keep in mind, if that had been subtraction, you would want to start by distributing the negative to the second parenthesis. If it had not been there at all, if the plus sign wasn't there, it would be a multiplication problem, just like number 9. But because this is addition, we're just adding like terms. So I start with the biggest thing, which would be our x to the 4th. It didn't have a like term, so I'm just going to write it down. The next term would be the x cubed, which is just, again, a normal x cubed, so plus x cubed. Now is when I start to have like terms. The 4x squared plus 4x squared becomes 8x squared. Because we're adding, we don't change exponents. We get a 2x and a negative 6x, that's negative 4x. And then a negative 21 and a plus 5, that's negative 16. And again, we're done. Some of these questions should feel really almost too easy. So just be careful to make sure you don't make it feel too easy and then make a silly mistake. Okay. Number 11, we're going to Cuba parentheses. The real reason that this question's on here is just to make sure you take the time to do things the right way. Yes, you could try to just sort of, oh, I'm going to cube the two terms and hope for the best, but cubing something means to multiply it by itself 3 times. So you really, truly need to take the time and distribute it through the 3 times. I'm just going to take 2 of these at a time, so let's talk about just this piece. If I distribute, I'm going to get 4x squared. Then I'm going to get 8x, but I'm going to get the same 8x here. So I'm going to write plus 16x. Because, you know, you get this 8x and this 8x, we know that's going to be 16x. And then the last step would be plus 16. That still needs to be distributed one more time by 2x plus 4. And that's basically what number 9 started with. We're going to go ahead and we're going to cruise through that. 4x squared times 2x is 8x squared. 4x squared times 4 is plus 16. Sorry, that was x cubed to start with. This would be a 16x squared. That guy's done. 16x times 2x, that would be 32x squared. And then 16x times 4, that's 64x. And the 16 is done. And then 16 times 2x is 32x. And 16 times 4 is 64. Leaving me with a grand total of 8x cubed plus 48x squared plus 96x plus 64. And that should be the end of number 11. After 11, we get into the factoring for the next 5 or 6 questions. Starting with 12, you're really focusing on trying to make sure you use all the different factoring approaches. 7x cubed minus 14x to the 4th. When I look at this, I recognize that there's something in common in both of the terms. And when I see that, I always start with a single parentheses, pulling out what's common. Both the 7 and 14 divide by 7, and I see there's at least x cubed in both of them. You're always taking the smaller exponent. So that means I've taken everything out of this first spot here, which means I'm going to replace it with a 1. It's still minus. Now 14 divided by 7 would be 2. And x to the 4th means I didn't take all of them, so I should have a leftover x. Okay. And 1 minus 2x doesn't factor. Number 13, x squared plus 5x plus 6. Just standard factoring, it'll be x and x. Factors of 6 that add up to 5 would be 2 and 3. Because the 6 is positive, the signs have to match. In order to add up to 5, I'm going to have a positive 2 and a positive 3. And that would be that question. 14 has 2x squared plus 9x plus 10. With this question, it's more about checking your answer than anything else. It's easy to write down 2x and x. With the 10, I think most of us would assume it's going to be 2 and 5, though it could be 1 and 10. But the biggest issue is that when I put it down, I still have to check to make sure it works. If I put a 5 here and a 2 here, this is 5x, this is 4x, and because the 10 is positive, I'm adding. If I add the 4 and the 5, I do get 9x. In order to be a positive 9x, it needs to be a positive and a positive. If I had done that and it didn't work out to give me 9x, that would just mean I need to try a different set of numbers or try to rearrange the numbers. Number 15, it's our good friend, the difference of squares, 4x squared minus 81. You'll notice the 4 and the 81 both have square roots. That's how I know to do this, and that there's a minus sign. So when I see that information, it's going to be 2x and 2x. The square root of 81 is 9 and 9. And because it's a negative 81, I have to have a positive and I have to have a negative. And that should be it. I really shouldn't have to check that as long as I'm taking my time. Keep in mind, it's a square root, it's not half. So 81 divided by 2 would be 40.5. You certainly shouldn't see a 40.5 in that question. Okay. Number 16 is our factor by grouping. It's x cubed plus 15x squared minus 2x minus 30. When you put in the grouping parentheses, it's really important that you keep the negative attached to the 2x. You wouldn't want to let it slide out and then have a difference of signs going on. That would be a lot of problems. In this first parentheses, it looks like x squared is what's common. And that leaves me with x plus 15. In the second parentheses, it's important to take the negative with the 2. So we're going to say negative 2. Whoops. And if I take that out, that leaves me with a positive x. And because I took a negative 2 out of a negative 30, it should come out positive 15. Because the parentheses match, I'm in a good place. And I should be able to answer with x squared minus 2 times x plus 15. All right. And then the last factoring question, I think, is number 17. I will give you the formula for this, y cubed plus 8. The formula is a plus or minus b, a cubed plus or minus b cubed equals a plus or minus b times a squared minus or plus ab plus b squared. The reason the signs are stacked the way they are is because if you're using a positive sign at the very beginning, you're going to use the top sign all the way across, which means you have a plus here, but you have a minus there. And if you use a negative, then it's the bottom sign all the way across. The key here is to recognizing what A is and what B is, because if you can figure out what those two things are, the problem's pretty straightforward. It looks from here that A must be Y. Where people get into trouble is thinking that B is 8. It's not 8. It has to be something cubed. So the question is, what number cubed is the same thing as 8? And the answer to that is 2. So in this case, B is 2. You're always going to be looking for what number is that value representative of. So I'm going to have y plus 2. Because it was plus here, I'm going to keep a plus. And then y squared for a squared. Here's where the sign switch happens. Instead of using a plus here, I'm going to use a minus. AB, that's y times 2, that'd be 2y plus b squared. Well, b is 2, 2 squared is 4. And that should be done with 17. Okay, so we just got a few more. Number 18 says we got x squared minus 2x minus 8, use that, over x squared minus 4x minus 21 times x squared minus 49 over 2x minus 8. First thing we want to do when we look at a problem like this is try to pull all the pieces apart and factor. We factor before we cancel. That's a really big idea. Everything that's x squared usually goes into 2 parentheses. Anything that doesn't have an x squared, it's usually just 1. So that denominator, 2x minus 8, it's probably just a GCF or a common piece. If I look at the top, I'm going to get x and x. Factors of 8 that subtracts to make 2 would be 4 and 2. In order to get a negative 2, obviously the signs are different because the 8's a negative. I'm going to want to go negative 4, positive 2. Then when I go to the bottom, I'm going to have x and x. Factors of 21 that subtract to make 4 would be 7 and 3. In order for it to be a negative 4, it would be negative 7 plus 3. I come over to the left side, that's a difference of squares, so that's going to be x plus 7, x minus 7. And then here in the bottom, they both have a 2 in common, so I pull a 2, I get x minus 4. That shows me this x minus 4 will cancel with that x minus 4. This x minus 7 will cancel with that x minus 7. I think that's about it. I'm going to get x plus 2 times x plus 7 all over 2 times x plus 3. As a side note, I want to make the statement that x cannot be negative 3 because that would make the denominator of the fraction equal to 0. So it's always good to make that distinction. Okay, number 19. Very similar. In fact, the only difference is that we're going to flip the second fraction. So we have x squared plus x minus 6 over 3x plus 9. And we were going to divide, but I'm going to times and flip the second fraction so that I don't have to worry about the division part of it. What that means is that I now have 6x minus 24 on top over x squared minus 4. So if you look at your original test, that was upside down, and we flipped it to make the division turn to multiplication. But the same process applies as the last question. Now that we've done that, we're going to have a single fraction, a single parenthesis on top, and a double on bottom over here. On the left, it's x and x. What are the factors of 6 that subtract to make 1? That would be 3 and 2. In order to get a positive 1, I'm going to need a positive 3 and a minus 2. On the bottom, it seems like they have a 3 in common. That would leave me with x plus 3. On the top over here, it looks like a 6 is in common. That leaves me with x minus 4. And then on the bottom, it's a difference of squares, x minus 2, x plus 2. I go through looking for cancellations like x plus 3 and x minus 2. But here's where sometimes we forget is these single numbers, when there's multiples of them, sometimes they reduce as well. So that 3 goes into 6 2 times, so that's a simple simplification there, leaving me with 2 times x minus 4 all over x plus 2, where x is not negative 2. Okay. 20 is one where we're just being asked to add two fractions. It says 3x over x plus 5. I'm going to put that in parentheses. Minus 2 over x. One of the first things I'll always say to do is to change this negative to plus a negative 2. It attaches the negative to the 2, which makes further distribution and other things it will do a lot better. The next thing I want to do is find the LCD. I need these two fractions to have the same denominator so I can combine them into one fraction. That's our goal. So we look at the denominators, and as long as we can't just multiply to make them the same, like x plus 5 is not the same thing as x. The only way to make them the same is to multiply them together. So I'm going to say the LCD is x plus 5. Now I just need to make sure that both of them have the same denominator. This first denominator seems to be missing an x, so to put it there, I have to put it on top, making it 3x squared over x times x plus 5. Over here on the right, it seems like I'm missing an x plus 5. So I'm going to multiply by x plus 5 on top and bottom, making it negative 2x minus 10 over x times x plus 5. At this point, I just want to combine any like terms across the numerator, and I keep the denominator the same. It should be x times x plus 5. The question is, what about the top? We've got 3x squared minus 2x minus 10 minus 10. Imagine that's a 10 for me. That should be in the... Okay, last question. Number 21. We have fractions built inside fractions. 2 over x minus 8 over x plus 3 all over, I'm going to put that in parentheses there, all over 3 over x plus 3 plus 5 over x. And as we go through and try to solve these, what we're looking to do is trying to just find the LCD. Now right away, I'm going to go ahead and change that to plus a negative 8, and then I'm going to go after the LCD. The LCD for this question is x times x plus 3. Now, when I want to simplify this out and clean it up, the goal here is to actually multiply the whole fraction, top and bottom, by the LCD. When we do that, okay, think about this distribution. This is all going to go on the top of the fraction. You think of the LCD as that over 1. So what that means is it's going to cancel the x in the first fraction, leaving with 2 times whatever didn't cancel. And the x plus 3 never canceled, so x plus 3 goes there. I'm going to get plus. As I distribute the second time, the x plus 3 should cancel, leaving me with just negative 8 times x. You think about that as the leftover piece. Now what's nice about that is the top fractions that were built inside the fraction are now simplified to a single line. As I go to the bottom, again the x plus 3 cancels, leaving me with 3 times just the x in the LCD. Plus 5, as I distribute here, the x cancels, and the 5 has to multiply by x plus 3. As I distribute, I'm going to get 2x plus 6 minus 8x over 3x plus 5x plus 15. Now I just combine my like terms. It's going to give me negative 6x plus 6 all over 8x plus 15. So now this is a little bit trickier. I don't know, maybe I messed up and didn't do it on the other one. I'll go back and look real quick, but on this question, it's a little bit trickier to find what x can't be. You think about switching the 15 to a negative 15, and then you divide by the 8. Okay, so that's what x can't be to prevent it from equaling 0. Here we didn't write on the previous question, x is not 0, that's for that guy, or negative 5. So those would have been included in the answer as well. Okay, hopefully that gets you through and answers all your questions. Come see me with your questions that don't get answered, and I'll see you in class.